All right. So our aim is to have NBMA environment so that we can test that 5 modes of OSPF NBMA. For that, I have taken a frame relay switch in the middle to connect these 4 routers, and I'm now putting PVCs, permanent virtual circuit. I'm having a DLC number 101 on port number 1, which is going to be connected to router 1, and 201 that's going to connect to router 2. And again on the same port 1, I'm going to have 103 and port number 330 301. Alright, similarly to connect to router 4 on the same port, I'm going to have 104 and this is going to be 40. So these are all like a MAC address for the frame relay port. DLC numbers are like MAC address. Like you have MAC address for Ethernet port. Here we define the MAC address called DLC number, data link connection identifier, for each circuit called PVC, permanent virtual circuit or private virtual circuit. And now I apply. So I got some interfaces now which I can use to connect these routers. I take a serial cable and connect between S40 and 1. And then again I connect from serial 2 to here S40. Similarly I connect from serial 3 and S40. Then I connect from serial 4 to S40. Right, connection is made. Let us decide the IP address. On R1 I would like to give 10.0.0.1/8. 10.0.0.2. 3 and 4. Now let us have some loopback behind R1 so that we can check the reachability. And not only that, OSPF will use the same as router IDs. Okay, so let us now begin from here. Let's begin the configuration using a notepad. I'll use notepad and this is the configuration for router 1. Is the font size okay for you? Right. Now, we will paste this before we enable OSPF. I want to show you something. I'll paste this on router 1. I'm not going to enable OSPF now. Let me paste this. Router 1. Similarly, router 2. Because it's a switch in the middle, frame relay switch in the middle, we have only layer 2. That's why all the routers are in 10 subnet. 2 is 10.0.0.2. And router 3, 10.0.0.3. And router 4, 10.0.0.4. Okay. You see this one, we have this IP address, but we will not be able to ping the remote device. Ping 10.0.0.1, you can't ping. The reason is the interfaces of routers are not frame relay now. The default, if you see, show IP, show interface serial /0. If you see, the default encapsulation type is HDLC. I want to show you that. You see, the default encapsulation type is HDLC. If you are talking to frame relay switch, it needs to be frame relay. So let us now go to serial /0 and say encapsulation frame relay. Did you understand this? We are changing the encapsulation type. After I say that, you see the line protocol is coming up. Till that time, the line protocol was down. Okay, why line protocol is down? Because the switch is already a frame relay. Switch is already a frame relay, so you have to configure this on the router side only. So here also I'll say interface serial /0 encapsulation frame relay. I repeat the same on the other two. Now if you try pinging from router 1 to 2, 3 and 4, you will be able to reach 10.0.0.2. You see it's pinging, pinging, pinging. Now let us try pinging from 4 to 2. This ping won't happen. Why? Because you don't have full mesh. What do we have now is what called as hub and spoke. You understand? Hub and spoke. Packet should go to hub and hub only have to route it to spokes. That's why you are not able to ping the same subnet another device. It is not taking a U-turn in switch. Frameless switch don't have a circuit to connect between router 2 and router 4 directly, or router 4 to router 3 directly. You cannot even ping router 3. Alright, this is because of hub and spoke. Okay, our aim is not to ping 10.0.0.2. Our aim is to ping 2.2.2.2, 3.3.3.3 and 4.4.4. So now what we will do, we'll enable OSPF. We'll enable OSPF. Interface loopback 0, IP OSPF 1 area 0. Interface serial 4/0, IP OSPF 1 area 0. Okay, you have just seen me configuring OSPF on all this 4 router, and you will not see neighbor. Why? Neighbors are not dynamically discovered in the default mode. What is the default mode? In NBMA, what is the default mode? Non-broadcast. I want to show you that. Show IP OSPF interface serial 4/0. If you put this command, you can see the mode. You see, the mode is non-broadcast. We did not configure this. It is by default. When you assign, when you put OSPF, on a non-broadcasting, when you put OSPF on a frame relay interface, this is what it is. And now you can see here the hello timers are 30, dead timers are 120, but hello packets are not sent. That's why it is waiting. Why hello packets are not sending? Because in NBMA, hello packets cannot be sent without the support of multicasting. Yeah, so we have to configure the neighbor manually. Right, so show IP OSPF interface brief. We see OSPF running here. We also see show IP OSPF interface brief. It's running here. We see everywhere show IP OSPF interface brief. It's running everywhere. But they are not forming neighbor. See, show IP OSPF neighbor. They are not forming neighbor. We need to configure neighbor manually. I'm going to configure them like this. Interface serial 4/0, IP OSPF, not here, I'm very sorry. Go under router OSPF 1, neighbor 10.0.0.2, remote, that's it. And now, if you don't want them to form a DR or BDR, then you can say priority for the neighbor is 0. which means they cannot participate in the election because we have hub and spoke. No, that priority is an optional command. I am doing this because I don't have full mesh and I want to have non-broadcast mode. I don't want to change to another mode, but there is no full mesh. Then what I'll do, I will say the other routers cannot become DR or BDR. See, the neighbor has come back. The neighbor has come up. No need. Loopback interface is not in frame relay. Now if you go and check the routing table, show IP route OSPF, you have the route from router 4. Slowly we will have the route from other routers as well. Now let us go to router 4 side and form neighbor. Router OSPF 1 neighbor. What's the neighbor address? Only one neighbor we have. What is that? 10001. Yeah, do show history. For router 4, how many neighbors? Only one. Only hub router, right? We don't form neighbor with spokes. So only one neighbor we will say. Because you don't have connection with spokes, do you? Okay. So let us now go to router 1 and check whether we are able to learn all the routes. Still not. Why? Let me go check router 3. Show IP OSPF neighbor. Show IP route OSPF. Why nothing is learned? Let us refresh. Clear IP OSPF process. I'm expecting the neighbor to come back again. Show one section router OSPF. Okay, these are the neighbors. Let me also do something. I will go under serial 4/0 and give high priority. IP OSPF priority 255 because I want this only router to be a DR. All other routers will not form BDR or DR. They will be only DR others. Show IP OSPF neighbor. It's still in two-way state. We need to wait. Oh, the others are saying we have priority 1. No, we have to go change there also. Interface serial 4/0. You know why this complication? It is because we are using non-broadcast mode for hub and spoke. Actually, in the real world, we should not use. We will switch to next mode. I'm trying to demonstrate and show you the problem when you have non-broadcast. IP OSPF priority. Here I'm putting 0. Likewise, I'll do in R3. Alright, so let's go now and check. See, this router 4 is taken DR posting. That's not correct. We need to refresh clear IP OSPF process. It will re-establish. It is an attempt state. It will do. Okay, the neighbor has come up. Now let us check show IP OSPF neighbor. See, router 1 is the only DR. There is no BDR, nothing. Because We have put priority on all other routers, 0. Okay. So all the other routers have got priority 0. They will never form DR or BR. They will remain as DR others. And they will form full adjacency with R1. So R1 should know all the routes now. Yes, it has learned about the spokes loopback. You see that? And now you can ping from here 4.4.4.4 with the source of 1.1.1.1 and ping from here 3.3.3.3 with the source of 1.1.1.1. They are able to ping. Not only that, you can even ping from R4, show IP OSPF, show IP route from here, this one. But the problem is, you remember when I was trying this, when I was trying to ping this address, it was not pinging. Why? Because we don't have direct tunnel, right? So what we have to do is, we need to tell frame relay to forward those packets to router 1 so that router 1 can forward it. You understand? This is frame relay issue. See, show frame relay map. Listen carefully. This has got only path to 10.0.0.1. There is no path for 10.0.0.3 or 10.0.0.2. Yeah? I need to tell that even to go to 10.0.0.2 and 3, you need to take this DLCI. I'm going to do that. See how to do it. See, these are all too complicated. These are all frame relay stuff. But just once in a lifetime, you can see this to get an idea. Frame relay map, frame relay, interface serial 4/0, frame relay map, IP, which IP? 10.0.0.2. If you want to send the packet to 10.0.0.2, send to DLC number 401 and broadcast. Similarly, for 10.0.0.3 also I should say. Likewise, I have to go to router 3, show frame relay. Even here you don't see for 2 and 4. So I say interface serial 4/0, frame relay, IP 10.0.0, DLC number 301, broadcast. Likewise for 10.0.0.4. You see, these are all statically given by us. Yeah. Now let me show you again on router 2. Show frame relay map. See, this is the only one and it is learned dynamically. We are going to give 2 static. DLC number 201 we give broadcast. Likewise. Okay. Now after giving frame relay map, I want to show you the table again. Show frame relay map. You can see here these 2 are added by us statically. Now if you go and ping from here, earlier from router 4 you were not able to ping 10.0.0.2, but now you will be able to ping you will be able to ping. So show IP route. You can even ping now 33333. You understand? Okay. So I would like to take you to the next mode, but not now, in the next session. I want you to do this once if possible. No, sorry. Don't try doing it. Watch this video twice or thrice to understand what is going on. Frame really and don't try to do it. It's a waste of time.